Hi, good afternoon. This is Levent Gürdemir, UTA astronomer and astrophysicist at UTA Planetarium. We are here together with another live star stream. We were not here last week because of all the crazy weather going on. And today we are going to talk about what happened last week. Of course, I'm not going to talk about the electricity and power situation. I'm going to talk about Mars landing because we couldn't do our special live stream that was going to be live at the planetarium in synchrony with NASA live stream. Anyway, we can still talk about it because over the week I got a lot of questions about what was the big deal about sending another rover to another planet. Yes, Jim.
Such a very unfortunate chain of events that led to us not being able to do the show last week. We had exciting things prepared for all of you guys. We were going to show you neat videos and do the stream in a new way that we haven't done before. So, needless to say, we're certainly disappointed we weren't able to bring you all the content we hoped to. But hopefully this week, right, Levent, is good. Hopefully it works out.
Yeah. And you guys are safe, right, Jim?
Yeah, but we're all fine where I am. Everything, I think we came out relatively unscathed. We're outside of, I live like outside of Fort Worth, where a lot of people around me didn't do too well, but yeah, I think it was okay.
Okay.
What about you?
Yeah, everything went fine. Just we had little issues, but not a big deal. And also, everything is pretty good and well in the university. So
Yeah, recovered now.
yeah, absolutely. Let's take a look at the Mars Perseverance and how it was successfully landed on the planet's surface. So first of all, the people ask, okay, what's the big deal? So let's talk about what is still the big deal about sending a rover to different planets. So first, let's still talk about where Earth and Mars are in the orbit. So let's look at the different scene before this one. All right, so here, as you know, there is a sun at the center and the planets are orbiting around the sun. So when we are designing our space missions and when we are going to send stuff, either people or the spacecraft to another planet, we cannot make planets stop for a moment and we send our stuff. So they are keep orbiting. So we cannot send from here to here anytime. We just need to wait for Earth and Mars get close to each other, and that happens almost every 1.5 years. So when they are closest to each other, we can launch a rocket and do calculations, and the Mars is orbiting too, and we can send it. So this is pretty much like you are trying to jump from a moving car to another car. So there's a lot of calculations goes into place, but what we can do it. So apparently we can just launch something successfully and it finds Mars and lands on Mars. So how about landing on the Mars? Is it a easy process? So let's take a look at how landing sequence goes. Apparently if you send something to a different planet and as your spacecraft gets close to that planet, the gravity of that planet will accelerate your spacecraft, and if you leave it uncontrolled, that spacecraft will end up crashing into the surface of the planet. So this is what you don't want to happen. We call it free fall on Earth. So to avoid free fall.
Didn't they do that before? Didn't they just crash land the rover? Right? A big beanbag?
Apparently, I mean, you know, surprisingly, there were a few crash landing missions designed that way, but those were completely different and served for different purposes too. But sometimes, and a lot of the time, actually, if you look at the history of the space missions or Mars missions particularly, a lot of spacecrafts, because the calculations were not done right or the designs were not done right, they ended up crashing on the surface of Mars. So that's very typical, and that happens at least more than 10 times just for the agency NASA, and I'm not counting even like the Soviet and Russian missions and some other space agency missions to Mars which were unsuccessful. So that's not an easy process.
I think that the Soviet Union had absolutely awful luck getting to Mars. Every mission they sent, just failure after failure.
Well, in 2 years, in the early 60s, they designed 5 spacecrafts to land on Mars surface, and they all turned out to be unsuccessful. So it's a big deal. It's still a big deal.
Well, Russia now, sorry, at least mostly. Maybe they'll have better luck. I know the last thing that they sent in 2014 also failed, unfortunately. But we'll hope maybe they have better luck in the future.
It's not easy to design something like this. Okay, so the first thing, the spacecraft needs to maneuver because Mars have air too. So if you leave anything uncontrolled, dropping into the Mars air, it will burn out. So you have to just do an entry maneuver carefully and find a way to slow down your craft. And this is the way they slow down. They used airbags. We covered it during last live stream. They used airbags for some missions, but they were also highly risky. So the first, they launch a parachute, slows down the aircraft to a certain degree. So at some speed, it just drops bottom heat shield protecting cover off. And then the rover is exposed. At that altitude, aircraft is also slowed down to a certain level. And finally, the shell, the aircraft or the spacecraft shell, releases another vehicle that have propulsion jets like these, and they turn on the engines and they slow down the aircraft even further, and there is a rover. The cargo is attached to this secondary spacecraft, and there's a crane. So at one altitude, the crane is released, the rover is softly touched, landed on or released on the planet's surface, and what happens is there is also some complicated engineering over here too, because after rover, this spacecraft releases the rover, it unchains or unhooks the crane and goes away to land somewhere else. So
this
why?
Seems way more complicated than it needs to. Am I wrong? I mean, it just seems like you'd expect them to land it like SpaceX lands their rockets on Earth, right? It just the rover comes in and it just lands with some engines, but they decided to have this space crane. Do you know much about the space crane? You want to talk a little bit about it?
Well, yeah, I mean, there are a few things like you don't want to land this on rover because it can damage, and also they didn't want these jets to create a crater for the rover, because rover can get stuck if it creates, so it doesn't get too close to the land, and it just goes away and finds somewhere else to land. So it releases the rover. So this is the new rover. So let's talk about the
question
rovers.
real quick, just to cut in before it's too late. So Patricia asks, will we go to other planets? And before I let you answer that, Levent, we have been to Venus, right? But maybe you want to elaborate a little bit more in terms of beyond landers.
Mm-hmm. Well, yes, we have been going to other planets. The rovers are specific mission because the rovers are looking for something important on the surface of Mars and even actually underground of the Mars. For the exploration of the solar system, since late 50s and early 60s even, we have been sending some spacecrafts to different planets. So that included Mars and Venus. And also there was a famous, in the back late 70s and early 80s, Pioneer and Voyager spacecrafts. They were designed to get close to each planet and do flybys. So those missions sent us an extremely valuable data and pictures and video. So we started understanding the dynamics of the solar system and structures of the planets. The first information, first close-up pictures were obtained with those pictures in the early 80s. But we need to think about it. So if we are targeting a planet now, which we have like the flyby missions and satellite missions and all over the place, not just Mars, we're just sending landers on Mars today because we are looking for something specific. If we find a good reason for another planet, yes, we'll go there too. But it's important that what this rover is going to do for Mars. Okay, let's continue.
One more question. Sorry. So this is from Kurt. Thank you, Kurt, for joining us again. Also, you too, Patricia. You guys are both here every week. Very grateful for you. So Kurt asks, including other countries' endeavors, how many vehicles has successfully and otherwise are currently sitting on the surface of Mars? Difficult question to answer. I do have the number, if you're ready for this. So the number of successful landings on Mars. Successful being key word there, kind of depends on how you define it, is 10. So there are 10 successful missions.
I don't remember the numbers, but Russians, I know at least 2 landers on the surface. And the first lander was, we talked in the last stream, that looked like a rectangular box. But they just lost the signal immediately. It was released to the ground of Mars. So it can be considered maybe a successful lander or maybe semi-successful lander. But yeah, it's there. So they designed a second lander too, and I don't know if they had any future landers designed. So it's still a big deal to the design, and after this spacecraft, by the way, after it reaches here, it travels 7 months from Earth to Mars. So you design something, send it out to space, it travels 7 months without any problem, and then finds your destination planet and starts all the landing maneuver, slows down, releases rover. And after this rover lands on the ground, there is another thing. That rover turns itself on, powers up everything, just takes their antenna and points the antenna to where? So that's another tricky thing. So this spacecraft, how does it communicate with Earth? There is a satellite previously sent on the orbit of Mars. So that there's a like your TV dish, right? So you just point your dish antenna to some satellite in the sky, so you get the signal. So there is a satellite orbiting around Mars, which was sent earlier, and it is orbiting. So this rover has little antenna, communicates with the satellite around Mars, and that satellite communicates with Earth on a satellite, and that satellite communicates with the ground. So there are batteries, of course, but these are solar operated devices. So you have to charge the batteries with the solar power, because there is unfortunately no wall plug on the surface of Mars that they can just charge themselves.
If I'm not mistaken, I think they did bring a little nuclear reactor in that thing. I'd have to quadruple check then, but I think they did.
Mm-hmm. Yeah, there may be like nuclear batteries or just small devices that produces power, but mainly they rely on, especially beyond their lifetime. So they are designed for 6 months and sometimes a year, but like Spirit and Opportunity lived several years. So they may have longer lifespan than design, which is good. All right, so let's talk about what actually happened last week. This is what what was designed, and there are fantastic pictures and video.
So I want to, before we show you what actually happened, this just blows my mind. Not only does the video itself just send shivers all over my body, but I want to very quickly show you guys clips of what NASA modeled and simulated what it would look like actively as it's happening. It's too cool to not include you guys, so here we go. We can watch this.
That's the animation. Yes, that's the animation part. So the lander, the spacecraft, is first going and finding Mars.
Go to that scene. That's
Deploying the parachute, slows down, releases the cover, and releases the other vehicle. And then this thing flies on autopilot. So remember, we just don't have control of the ground because it's too far. And then it releases the rover with crane and flies off to a different place to land. So this is what happened on February 18th, last week. And
just incredible. Now, let's show them
Let's
the real one.
show the real one, yes. The real one went pretty similarly to the animation one, because the animation was done based on the design. So it was made by the same people, at least with the consultation from the same people.
Okay.
But the actually, yes.
We ready?
Mm-hmm.
Here it comes. This is exciting.
We are starting the straighten up and fly
So
right
this
maneuver,
has never
where
been
the
done
spacecraft
before.
will
They
jettison
actually,
the entry balance masses in preparation for parachute.
I'm turning that down a little bit. They actually installed for the first time cameras all over the rover as it was landing.
Yeah, those are all real camera recordings from the spacecraft itself. So it deployed the parachute, and as you see, everything is just colorful, just like your webcam you use all over the place today. And they couldn't do that before because transferring images and video was a big deal for these small devices, and especially over the satellite transmission link. But they have now fast enough processors and storage devices, and they are like lightweight. You don't want to put, like, probably back in the times we sent Pathfinder on the surface of Mars, if you wanted to include like 2 gigabytes of hard drive, it would take probably at least maybe like 3-4 pounds of weight, which is a significant thing for that the vehicle.
This is so crazy because this looks exactly like the simulation. I mean, so much of it is so similar that it just the feeling of actually being there is just
Exactly.
phenomenal.
Yeah, we were only able to establish this clarity and resolution with animations. But now, rather than computer renderings, we are looking at actual recording of that robot, which is great.
Also, this is essentially being filmed with something like a GoPro. It's not a GoPro, so we're not like supporting the brand or anything, but the camera that inspired this was a GoPro. One of the director's daughter was doing gymnastics. Ooh, we just missed something exciting. And she did a front flip with the GoPro on, and he was like, oh my goodness, what if we put this on the rover?
Yeah, it's amazing picture and amazing
We
video.
just missed the firing. So the sky crane and the rover just kind of, there was a little bit of a shake you might have just seen. The sky crane and the rover just left that outer shell. You can see in the image down below.
Yeah.
This is where things get really crazy.
And imagine, a lot of things can go wrong in this sequence.
In the upper left, we have the view from the rover, and then in the and then the lower left, we have the view from the sky crane. So you can see it lowering itself on, and then the last image, if you look at the upper left, you don't see any engines firing, and the engines are they are firing. There is flames there, but they are essentially see-through. So it's just at the same time, it's the type of fuel they use.
I mean, this is amazing. It just dropped the rover and flew off. And I can feel for all the people, and I would do the same thing if I were there and be in the team. So that's amazing. That's not. It's a big deal to do these type of things, and it is certainly and a great engineering design. Still, we are able to do that. So. All right, this is another camera showing
This is the first image taken right after it landed. This is one of its hazard cameras. These are the HazCams, as they're known. They're just kind of there to check to make sure there's no like big rock, or if they get stuck, they can see around the base. So it's also kind of covered. You can see that it's a little bit obscured because it has dust covers on everything still. But super neat to see rocks and so on and so forth.
Well, it is, I mean, certainly to just entertain the news. They have great colorful cameras, but what NASA engineers say actually they get better data from black and white pictures, because they take less space and contain more information about especially the terrain, and those are hazard cameras, so they don't want to just drive the rovers into like a big rock or a place where they can get stuck, like the Spirit and Opportunity. The Spirit, I guess, the one who got stuck in a mud. So so yeah, I mean, those are the great images, and this is just another colorful image view from Color HazCam. Yeah.
First color image. And Kurt, just recognize your comment. We had a couple of you guys blown away also. I mean, it is stunning. Definitely, I get goosebumps. I don't know if you guys call them that. There's so many names for that, but those videos combined look like the opening scene of a Hollywood space. So it is just, it's unbelievable. Really blows my mind.
It's just the idea that this is different planets, and this thing is going on in different planet. That's amazing. So those rovers and robots are doing great job on the planets, the different planet surface, and certainly it is much cheaper and also safer than sending humans to the different planets, because I mean, if you think like they can do everything that pretty much we can do, and this is a car size, just maybe a sedan size rover rolling on the surface, and this one has a drone with it. So there was in the cargo, there was not only the rover itself, and the rover has a partner drone, helicopter drone. So that drone will be also cool to see, because it will fly and it can go a lot faster than the rover itself, and it will find interesting places for the rover, and it will guide the rover for interesting point of interests. All right, so
neat facts about this rock, or this image in the bottom left, Levent. I don't know if you can kind of help point us out here, but these rocks right here, they have these holes in them down here at the bottom.
These rocks, yeah.
Yes, and these are signs, as far as geologists have already expected, that this is what water would do to rocks. Yeah. Water inside of rocks getting in there, and then temperature changing, causing these type of little notions. So they're definitely at ancient water beds, and the next hope and the point of the mission is to find signs of life, which is that's crazy.
Yeah, the rocks were investigated by the previous one of the previous rovers called Mars Science Laboratory in great detail. But the main mission of the Mars Perseverance is going to be looking underground, because Scientists are hoping to find fossil life, if not actual life. Because yeah, we know that on the conditions surface, on the surface conditions are rough on the planet, and so far we were not able to see any signs of either fossils or maybe like a bacteria and the small plants and anything. It's completely dry, but when we go into the underground, we may actually find surprising things. So what we are looking for, maybe finding some bacterial life underneath, or maybe a fossil life underneath.
Yeah, so this is a closer view. You guys can see here in this image of those rocks right
Yeah,
next to the wheel. The holes in it.
You can actually find similar rock formations around rivers. Yeah, the water make, I don't know the actual process, but make holes and they turn into a sponge-looking rock.
That's a great way to describe it. It does look very spongy.
Mhm.
But yeah,
You
they're
cannot
hoping,
squeeze them. I
like
mean,
you said, they're hoping to find bacterial mats,
mhm.
or something like those that you find on Earth. Who knows? It's exciting.
And that's a great wheel, by the way. That's different than the wheels of spirit and opportunity, right? Because they.
Yeah. Or curiosity. But yes, I have a comparison of that somewhere. Let me give me just a couple of moments, and I'll get that comparison
Sure.
ready for you.
Well, it's always great to have these type of tools on the different planet surface because they bring
Here we go.
amazing.
You guys can see.
All right, so yeah, the different design. So curiosity, perseverance.
I also saw a very funny image of a view inside of Perseverance's wheel, and there's some rocks in there, and somebody making comments about how those rocks are going to be stuck there for the next 40 years or however long it lasts.
Very nice looking rims, by the way.
Yeah.
That may inspire. Maybe it may inspire some of the rim makers.
You'd only hope that they have spinners on there. I don't know why they don't have spinners.
Maybe they were not allowed on the Mars surface.
It's illegal. Yeah. Mars code doesn't allow for it.
All right, yeah, that's all we can report from the last week's
I have
successful.
one more
Yes.
image, one more cool thing that I want to show. I just think it's so neat. It's a small thing, but it's super cool, at least in my opinion. So, as you guys know, if you drive around today, it's not as popular today as it was before, but let's just say 3 years ago, driving up behind somebody and seeing the little family stick figure on the back of their car window was extremely common. And then people started putting like dogs and all kinds of other ridiculous renditions and versions of it. Well, they decided to add this to Perseverance. So on the side of Perseverance, you guys can see in this image.
So was that on Perseverance?
Yeah. This is on.
That's funny.
So on the far right, you have Perseverance, and then just to the left, you have Curiosity, and then you have Spirit and Opportunity, also two twins, and then teeny tiny little baby on the far left.
Is that Pathfinder?
Sojourner, yeah.
The Sojourner,
same,
yeah.
but yeah, same.
Wow, yeah, that's a great family of rovers. I hope to see on the cars around.
Yeah. Maybe I need to get one of those images for myself. We have a message from Kurt, so I'm going to pull this up. You guys can see me looking away. I'm juggling a lot of stuff here, so please forgive me. Anyway, question from Kurt. What is your take on the first permanently manned industry to take hold on Mars? Will it be industrial mining, high-end tourism, military presence? That's my guess. Scientific labs? What do you think, Levan?
That's a great question. I would take it would be maybe production of livable air environment for maybe future human visitors. That would be starting from the oxygen and some other like the usable air for humans. Well, for other things like for example For mining, I don't think Mars resources are great. Well, we don't know what's in the deep, but we know like there are not a high value elements on the surface. You don't find a lot of like gold or uranium and things like that on the surface of Mars. So it would not be a great point of interest. I would look into the asteroids for those type of mining operations. High-end tourism, it's too. I mean, who want to travel 7 months and back and forth, make 14 months to see Mars? So I don't think that's going to be very popular tourism destination when it is possible and economical. Military prisons, it's too far. I would think there would be any threat. And again, like if you put something for military purposes on the surface of Mars, remember, Mars is only 7 months away when it is at the closest position. So as Mars orbits and Earth orbits, Mars gets farther and farther. So your military base is pretty much drifting away from Earth, which is even being less useful for you. And scientific labs. For some of the things, yes. I mean, the scientific labs can be a great place, but again, there would be a significant reasoning behind it, why you want to put your lab on the surface of Mars. What are you trying to establish? If you answer that question great way, which forming some of the plants were thought on the surface of Mars that may bring the conditions, the atmospheric conditions on the surface of Mars into a livable condition. Yes, there may be a great research lab for that, but it's going to be expensive. It's going to be fortune. I mean, it's going to cost fortune to maintain, but yes, why not? If we have the money, I would all vote for it.
Realistically, you're definitely right. It will be a scientific base, and just so the viewers know, my comment about military presence was kind of a joke. Do I think that it's likely at some point? Probably. The U.S. puts military everywhere, but
even on Mars.
it's only a matter of time. Maybe it won't be. We'll hope. Fingers crossed that it's just scientific labs. And industrial mining will I think you kind of touched on that. It's probably going to have to happen to some extent. Maybe not industrial, but they're going to have to start using stuff on Mars to make Mars livable if we're going to actually have people there long term, like on the space station.
Yeah. Well, a lot of these discoveries are driven by the great scientific questions. And for Mars, as we explained in the previous live streams, we are looking for specifically for the life. Because Mars seems like if we think about the beginning of life and the early time in the history of the solar system, Mars seems more conducive to life than Earth. And here is the question, why we don't see the life, or we couldn't find the evidence for life on Mars, and we know there is life on Earth. But we are also thinking that if the theory is correct, and the Mars had the life in the first place, and the life migrated onto the surface of Earth, so what happened to the life on Mars? Before we address those questions, our scientific understanding of how the life formed and started in the solar system will be very limited. So that's why we are trying to explore Mars. Well, I hope to see you next week on another live stream. And if you have questions, please join our live stream and get your questions in the chat. So, see you next week.